everyone. In this video we are going to discuss the second problem which came in MMath 2023. So the problem is saying that prove that x to the power n is a solution to the differential equation y double dash plus px y dash plus qx y is equals to 0 on the interval closed and bounded interval -1 to 1 for some non-zero real polynomials px qx if and only if n is equal to 1. So this is an if and only if statement first of all, and second of all, like, we are going to approach the solution considering that n is an integer, otherwise you may not be able to prove it. Okay, so try it out on your own, then you will realize that if n is not an integer then it might not satisfy. Okay, so yes, now talking about if n is an integer, so first of all it can't be a negative integer because you can very well see that then you have to define what is at 0, and mostly like it has to be differentiable again twice at 0, so that also you will have problem. So because the interval is given from -1 to 1, so n is so that implies basically that whatever be n, so it's always greater than equals to 0. Now coming to the very first case, that is n is equals to 0. If n is equals to 0, you can see that it's x to the power 0, which is 1. So 1, if you twice differentiate 0, if you once differentiate it 0, so it's basically becoming q of x is equals to 0. So that is implying that q of x is equals to 0. So now if a polynomial is totally 0 on an interval, so that means you can very well see that that polynomial q of x has infinitely many roots, so basically it identically becomes 0. So that implies that q of x is identically 0, so it's a 0 polynomial, and it's thus it's given that for some non-zero real polynomial, so that means like this case is again n equals 0 doesn't satisfy our condition. So what about case 1, case 2, that is x is equals to n is equals to 1. So that is y is equals to x. So let's see what our basically that equation boils down to then p of x times 1 plus q of x times x, and that should be 0. Now we have to, like, if we can consider that let's say that we consider p of x to be equal to x and q of x to be the polynomial which is -1. Okay, so then you see that it's like p of x, q of x are satisfying the conditions, and we are getting that this sum is 0. So that means n is equal to 1. So when n is equals to 1, it satisfies the solution, but try to notice that it's an if and only if condition. So we have just showed one way. Now let's consider case 3 where n should be like then greater than equals to 2. So if it's greater than equals to 2, then if I differentiate it, so what do I get? Like n times n minus 1 times x to the power n minus 2 plus n times x to the power n minus 1 p of x plus x to the power n q of x, and that should be equals to 0. Okay, so now this is the equation which is boiling down to, and now you can very well understand that since this is also a polynomial, okay, finally, like if p of x, q of x are polynomials which are given, so this as a whole should again be a polynomial, and if that polynomial is like 0 throughout that interval -1 to 1, so it's equivalent to 0. So it's a 0 polynomial. If that's a 0 polynomial, then every coefficient should be equal to 0. So which tells us that like n times n minus 1 should be equal to 0, and that is only possible like when so other coefficients will also be 0, but coming to the very first coefficient, so what do we get is that n can be 0, or we can see that n can be equal to 1. Now we saw that like n equals 0 again doesn't work. We saw that in case 1. Now like n equals 1, it works, and that's the only possibility we can see. So if y equals x to the power n satisfies if and only if n is equals to 1, and that's the proof. And yeah, so that's it for this video. So thanks for watching, and if you like the solution, so please like the video, and yeah, see you in the next one.